You are floating now, not in water, not in air, but in something softer than either, something that holds you with perfect gentleness, and you do not need to move, do not need to steer yourself anywhere, because you are exactly where you need to be, suspended in a place between waking thoughts and the quiet darkness that comes after. And as you drift here, you begin to notice something curious, something that draws your attention not with urgency but with the softest whisper, like a memory of light from very far away. And you realize that you are moving through space, real space, the kind that stretches between stars, but you are safe here, protected by an invisible warmth that keeps you comfortable as you travel. And there is no cold, no emptiness, only this gentle sensation of drifting forward, always forward, through a darkness that somehow feels friendly, welcoming, as though it has been waiting for you to arrive. The stars around you are not the bright piercing points you might see from Earth on a clear night, but something softer, more like candles seen through frosted glass, their light reaching you after traveling for so long that it has become tired, peaceful, ready to rest alongside you. And you understand without anyone telling you that each of these lights began its journey long before you were born, before anyone you know was born, crossing distances so vast that numbers cannot really capture them, and yet here they are, arriving at your eyes at this exact moment, this quiet moment of you drifting. And there is something deeply comforting about this, about being part of a universe where light travels patiently, never rushing, always moving at its own steady pace through the dark. You notice that your body, if you can still call it that, feels different here, lighter in a way that has nothing to do with weight, as though you have become less solid and more like the space itself, more like a thought that has taken shape just barely, just enough to experience this journey, but not so much that you feel heavy or bound by anything, and your breathing, you realize, has slowed to match the rhythm of something larger, something cosmic. Each breath in taking the same time as a distant star's pulse, each breath outlasting as long as the gentle expansion of a nebula somewhere in the far reaches of everything. And this synchronization feels natural, feels right, as though you have always been meant to breathe this way, slowly, peacefully, in harmony with the universe around you. The darkness here is not empty, you can't understand, but full of things too small and too faint to see directly, particles that drift alongside you. Cosmic dust that was once part of stars that lived their long lives and then released their elements back into space, and these tiny fragments carry with them the memory of fusion, of atoms pressed together in stellar cores where pressure and heat transform simple hydrogen into helium and then into heavier elements, carbon and oxygen and iron, all the ingredients that would someday form planets and oceans and the very cells of living things. And you are surrounded by this ancient dust, moving through it like a slow swimmer through a sea of starlight and possibility, and each particle you pass is its own story, its own billion-year journey from stellar fullness to this quiet moment of drifting with you through the dark. Time feels different here, stretched and soft like honey poured slowly from a jar, each moment lasting as long as it needs to, expanding to hold whatever thoughts arise and then dissolve again, and you begin to understand that time itself is not the rigid thing you once imagined, not a straight line moving forward with mechanical precision, but something more fluid, more responsive to the universe around it. And scientists discovered this, you recall, in a dreamy way. Discovered that time moves differently depending on how fast you travel and how deep you are in a gravitational field, and this discovery came from thinking carefully about the nature of light, about how light always moves at the same speed no matter how fast you yourself are moving, and this simple fact, this constancy of light speed, revealed that time must be flexible, must adjust itself to keep light speed constant, and so time bends and stretches like a gentle fabric, and here in your drifting state, you feel this flexibility, this softness of time as you move without hurry through the spaces between stars. You pass by something that might be a planet, though from this distance it appears only as a slight darkness against the greater darkness, a shadow that suggests solidity, and you wonder in a lazy, comfortable way about what might be on its surface, whether there are mountains there, shaped by ancient volcanic flows now long cold, or vast plains of frozen methane, or perhaps oceans beneath a thick crust of ice, protected from the cold of space, holding liquid water that has remained undisturbed for millions of years, and these oceans, if they exist, might contain life, simple life perhaps, single-celled organisms that have never seen sunlight, that know nothing of the star the planet orbits, but that live nonetheless, metabolizing chemicals that seep up from hydrothermal vents in the ocean floor, creating their own energy from the heat of the planet's core. And this possibility, this thought of life finding a way even in the most unlikely places, fills you with a quiet satisfaction, a sense that the universe is more generous than it might first appear, more willing to allow complexity and consciousness to emerge wherever conditions align, even in the dark, even in the cold. Gravity is what holds the distant planet in its orbit. You remember, gravity, which is not really a force pulling things together but rather a curvature of space itself, a bending of the fabric of reality caused by the presence of mass. And you imagine this as you drift. Imagine the planet creating a gentle dip in the smoothness of space, like a heavy ball placed on a stretched sheet, and anything that passes near this dip will naturally curve toward it, will follow the bent contours of space. And this is what orbiting is, simply moving forward through space that has been curved into a circle by the presence of mass, and you yourself are moving through curved space right now, following paths that have been laid out by all the massive objects around you, the stars and planets and clouds of dust, each one contributing its small or large curvature to the overall shape of space, and together they create the geometry through which you glide effortlessly, without resistance, as natural as a leaf floating downstream. The light from a nearby star, closer than most but still unimaginably distant, reaches you now, and you perceive it not just with your eyes but with your entire being, feeling the gentle pressure of photons against your form, each photon a tiny packet of energy that was created in the core of the star through the fusion of hydrogen atoms, process that releases energy because the helium atom that results weighs slightly less than the 4 hydrogen atoms that combine to create it, and this missing mass has been converted to energy according to the most famous equation in physics, the one that tells us energy equals mass times the speed of light squared, and that speed of light is so large that even a tiny amount of mass converts to an enormous amount of energy. And this is why stars shine, why they can burn for billions of years, slowly converting their hydrogen fuel to helium and releasing light and heat in the process. And the photons that are released from these fusion reactions in the star's core do not immediately escape, but instead begin a long random walk outward through the dense plasma of the star's interior, bouncing from atom to atom, taking thousands of years to work their way from the core to the surface. And only then, finally free of the star's dense mats at you, they fly straight and true through space toward you, crossing the distance in hours or years or centuries, depending on how far away the parent star happens to be. You let yourself sink deeper into this drifting state, feeling your thoughts become slower, more widely spaced, like stars themselves, each thought a bright point surrounded by comfortable darkness, and you notice that you are no longer trying to hold on to anything, no longer trying to remember or plan or figure out, but simply allowing yourself to experience this journey through space, this slow educational drift through the cosmos. And there is a part of your mind that is still aware, still listening to the gentle explanations that arise unbidden from somewhere deep in memory or imagination, explanations about the nature of matter and energy, about atoms and molecules, about the way everything you have ever touched or seen is made of the same fundamental particles arranged in different patterns, protons and neutrons clustered in nuclei, electrons orbiting in the probability clouds, and these particles themselves are made of even smaller things, quarks held together by gluons, and the force that holds them is so strong that you can never isolate a single quark. They exist only in groups, bound together permanently, and this makes you think about connection, about how even at the smallest scales, things are connected, held together by forces that cannot be broken, and perhaps this is true at larger scales too. Perhaps you are connected to everything around you in ways you cannot directly perceive, but that are nonetheless real, threads of causation and relationship that link you to the stars and planets, to the atoms that make up your body, atoms that were forged in ancient stars and scattered into space when those stars died, and later gathered into clouds that collapsed to form new stars and planets, including the sun and earth. And so you are made of stardust, quite literally, a body composed of elements that could only be created in the intense heat and pressure of stellar cores, and this realization, this understanding of your connection to the cosmos settles over you like a warm blanket, comforting and complete. The nebulae you pass, vast clouds of gas and dust spread across light years of space, glow softly in shades of red and blue and green, colors produced when the gas is energized by radiation from nearby stars, ultraviolet light that strips electrons away from atoms, ionizing them. And when these electrons recombine with atoms, they release light at specific wavelengths, specific colors that correspond to the energy difference between electron orbits. And each element produces its own characteristic colors: hydrogen glowing red, oxygen giving blue-green, nitrogen contributing to the reds, and together these emission lines create the beautiful colors you see in images of nebulae. Though your eyes here in this dream journey perceive them as more muted, softer, less saturated but more peaceful, and you understand that these nebulae are still in nurseries, places where new stars are being born from the gravitational collapse of dense regions within the cloud, places where gravity has overcome the outward pressure of gas and pulled material together into tighter and tighter clumps, heating them through compression until at their centers the temperature and pressure become high enough for fusion to begin, and a new star ignites, pushing back against the surrounding gas with its radiation and stellar wind, clearing the space around itself. And this process of star birth is happening constantly throughout the galaxy, old stars dying and releasing their material, new stars forming from that material. An endless cycle of creation and destruction, though destruction seems too harsh a word for the gentle dispersal of the stars' outer layers into space, a final gift to the cosmos, a seeding of heavier elements that will allow future generations of stars and planets and perhaps life to have great chemical complexity. Your sense of scale has become wonderfully fluid. Sometimes you feel immense, as large as a solar system, able to cut planets in your palms like marbles, and at other times you feel impossibly small, smaller than an atom drifting through the quantum film of space-time itself, where the smooth fabric of reality gives way to chaotic fluctuations at the tiniest scales, where virtual particles pop into existence in particle-antiparticle pairs and then annihilate moments later, where the very notion of distance and duration becomes fuzzy and uncertain, governed by Heisenberg's uncertainty principle, which tells us that we cannot know both the position and momentum of a particle with perfect precision, that there is a fundamental limit to how much we can know about the state of a quantum system, and this is not a limitation of our measuring instrument but a deep feature of reality itself. And somehow this uncertainty, this built-in fuzziness at the foundation of everything, feels appropriate here in your drifting sleep journey, where certainty and clarity are not the goal, where instead you seek the soft blur of almost sleep, where thoughts and dreams intermingle, where scientific fact becomes poetic understanding, where you can appreciate the beauty of quantum mechanics without needing to solve its equations, without needing to calculate probability amplitudes or eigenvalues, but simply feeling the strangeness and wonder of a universe that is at its core uncertain, probabilistic, filled with superpositions that collapse only when observed. And what does that even mean? You wonder in a distant way. Does it mean that consciousness plays a role in determining reality? Or is observation something more abstract, simply any interaction that creates a correlation between systems? And you do not need to answer. You let the question drift away like everything else, like thoughts and worries in the busy noise of daily life, all of it becoming quieter, fading into the background as you move forward through space. A galaxy appears in the distance, a vast spiral of stars slowly rotating, and you know without calculation that it is turning at a speed that should by all rights fling its other stars away into the void. The stars are moving too fast for the visible mass of the galaxy to hold them in their orbits, and yet they remain spinning around the galactic center in elegant curves, and this paradox led astronomers to propose the existence of dark matter, an invisible substance that does not emit or absorb light, but that has mass and therefore gravity, and this dark matter forms a vast halo around galaxies, providing the additional gravitational pull needed to keep the outer stars in their orbits, and estimates suggest that dark matter outweighs ordinary matter by a factor of 5 or 6, meaning that most of the mass in the universe is made of something we cannot see, cannot touch, cannot detect except through its gravitational effects. And this is both humbling and exciting. Humbling because it shows how much we still do not understand about the universe. Exciting because it suggests there are still deep mysteries to explore, fundamental questions about the nature of matter and reality that remain unanswered, and you find comfort in this, in the idea that the universe still has secrets, still has wonder to reveal, that we have not figured everything out, that there is still room for discovery and surprise. And as you drift past this galaxy, you feel the pull of its dark matter halo, a gentle tugging that is more felt than seen, presence in the darkness, patient and silent. The concept of darkness itself becomes interesting to you as you float here, surrounded by it, cradled by it, and you realize that darkness is not the absence of anything, but rather simply the absence of visible light, and visible light is just a tiny slice of the electromagnetic spectrum, a narrow band of wavelengths between about 400 and 700 nanometers, wavelengths that our eyes happen to be sensitive to. But above and below this visible range stretch vast domains of electromagnetic radiation that we cannot see, radio waves with wavelengths of meters or kilometers, microwaves with wavelengths of millimeters, infrared with wavelengths just longer than red light, and then on the other side of the visible spectrum, ultraviolet with wavelengths just shorter than violet, X-ray shorter still, and gamma rays with wavelengths smaller than atoms. And all of this radiation is light, all of it travels at the same cosmic speed limit, but our eyes perceive only the tiniest fraction, and so what you call darkness might be blazing with radio waves or humming with microwaves, and in fact it is. The cosmic microwave background fills all of space with radiation left over from the Big Bang, cooled now to just a few degrees above absolute zero, but still present, still detectable. A whisper of the universe's violent beginning now, faded to the gentlest hum, and this radiation is uniform in all directions, with only tiny fluctuations from place to place, and these fluctuations, measured precisely by satellites, tell us about the conditions in the early universe, about how matter was distributed shortly after the Big Bang, about the seeds that would grow through gravitational attraction to become the galaxies and clusters of galaxies we see today. And so even the darkness carries information. Even the empty spaces between stars are filled with stories written in wavelengths our eyes cannot perceive, but our instruments can measure and our minds can understand. You become aware of your own breathing again. Notice how it has slowed even further, each breath taking longer than the one before. And this seems natural, seems right, as though you are gradually aligning yourself with longer and longer cosmic rhythms. Breathing in sync with the rotation of galaxies, with the oscillation of pulsars, with the slow drift of continents on planetary surfaces. And there is no hurry, no deadline, no place you need to be except here, drifting and learning and slowly descending into deeper rest, and the voice in your mind that has been explaining these cosmic phenomena, whether it is your own voice or something other, grows softer now, more distant, as though it too is drifting away, following its own trajectory through space, and you do not mind. You do not try to hold on to it. You let it fade. Let the explanations become simpler, more basic, more like lullabies than lectures, and the stars around you pulse gently, their light rising and falling in slow rhythms, and you wonder if you are imagining this or if some of them are variable stars, stars whose brightness actually does change over hours or days or weeks, pulsating as they expand and contract, or eclipsing binary stars where one star passes in front of another from your perspective, temporarily blocking its light. And these stellar variations are useful to astronomers. They allow measurements of distance and mass and luminosity. They turn stars into cosmic measuring sticks, but for you now, they are simply pretty, simply soothing, like watching candles flicker in a darkened room, and you feel your eyelids, if you still have eyelids, growing heavier, and you allow them to close, and somehow you can still see the stars, still perceive the vastness around you, as though your awareness has become independent of physical eyes, as though you are perceiving directly with your mind. And this seems perfectly natural here in the soft reality of your journey. Momentum and energy drift through your thoughts now, these fundamental concepts of physics that describe motion and change, and you understand in a dreamy way that momentum is simply mass times velocity, a measure of how much something has, how hard it would be to stop. And energy comes in many forms: kinetic energy of motion, potential energy of position, thermal energy of heat, chemical energy stored in bonds between atoms, nuclear energy locked in the cores of atoms. And all of these forms of energy can convert into one another, but the total amount of energy remains constant. Energy is conserved, never created or destroyed, only transformed. And this conservation law is one of the deepest principles in physics, arising from the symmetry of time, from the fact that the laws of physics do not change from one moment to the next. And there is something profound about this, something that connects mathematics and physical reality in an intimate way. The mathematician let me know the proof that every symmetry in physics corresponds to a conservation law. Symmetry in time gives conservation of energy. Symmetry in space gives conservation of momentum. Symmetry in rotational orientation gives conservation of angular momentum. And these conservation laws constrain what can happen in the universe. They place limits on change. They ensure that certain quantities remain constant even as everything else transforms. And this gives the universe a stability, a predictability. Even in chaos, there are these threads of constancy running through everything, and you find this deeply reassuring. The idea that underneath all change, underneath all transformation and evolution, and the endless dance of particles and waves, there are these unchanging truths, these conservation laws that have held since the beginning and will hold until the end, if there is an end. And you rest your awareness on this thought, this idea of constancy within change, and it supports you like water supports a swimmer, and you float there, held by the laws of physics, cradled by the universe's deep mathematical structure. A moon passes nearby, tidally locked its planet so that it always shows the same face toward the world it orbits, just as Earth's moon shows only one face to Earth, and this tidal locking happens because of the way gravity varies with distance. The side of the moon closer to its planet feels slightly stronger gravitational pull than the far side, and this difference, this tidal force, creates a bulge in the moon, pulling it slightly out of perfect circle shape. And if the moon is rotating relative to its planet, this bulge does not stay aligned with the planet but tries to rotate with the moon, and the planet's gravity pulls on this bulge, creating a torque that slows the moon's rotation. And over millions of years, this torque brings the rotation period into synchronization with the orbital period, so that the moon turns once on its axis in exactly the same time it takes to orbit once around its planet, and thus it becomes locked, forever showing one face to the world it orbits, and the other face, the far side, remains hidden from the planet's view though not dark. Both sides receive sunlight. The far side is not a dark side except in the poetic sense of being unseen, and you think about this, about how long it takes for tidal forces to lock a moon's rotation, millions or billions of years of patient gravitational tugging, and you appreciate the slowness of this process, the way the universe operates on timescales that make human lives seem like brief flickers, and yet those brief flickers can understand these vast processes, can work out the mathematics and predict the outcomes. And there is something beautiful about this, about consciousness arising in the universe and turning back to understand the universe itself, about the cosmos becoming aware of itself through us, through any beings anywhere who wonder and calculate and come to understand the laws of nature. Your thoughts turn to temperature, to heat and cold, and you understand that these are not substances but measures of molecular motion. Temperature is the average kinetic energy of particles, atoms and molecules jiggling and vibrating and spinning and moving, and the faster they move the higher the temperature. And heat is the flow of this kinetic energy from hot regions to cool regions, from fast-moving particles to slow-moving particles, and this flow continues until equilibrium is reached, until everything is at the same temperature. And this is entropy. This is the second law of thermodynamics, the tendency for energy to spread out, for concentrated useful energy to become dispersed and less useful for order to become disorder. And this law gives time its direction, its arrow, because while most laws of physics work equally well forward or backward in time, the second law does not. Entropy always increases in closed systems. Time flows in the direction of increasing entropy, and this makes you think about the ultimate fate of the universe, whether it will expand forever, growing colder and more dilute as entropy increases toward its maximum, or whether it might suddenly stop expanding and begin to contract, all the matter in the universe falling back together in a big crunch, or whether something else entirely might happen, and current observation suggests that the expansion is accelerating, driven by something called dark energy, an even more mysterious component of the universe than dark matter, an energy that seems to be inherent to space itself, that pushes space apart. It grows stronger as the universe expands because there is more space and therefore more dark energy. And if this continues, the universe will indeed expand forever, galaxies moving away from each other at ever-increasing speeds, until eventually each galaxy is alone in its observable universe, unable to see any others because the space between them is expanding faster than light can cross it, and the stars in each galaxy will eventually burn out, white dwarfs and neutron stars and black holes cooling slowly in the darkness, and even the black holes will eventually evaporate through Hawking radiation, and the universe will approach a state of maximum entropy, a heat death where nothing can happen because there are no energy differences left to drive change. But this is trillions upon trillions of years in the future, so far away that contemplating it feels like contemplating infinity, and you do not worry about it. You let it remain a distant abstract possibility, and you return your attention to the present moment of your drifting, to the stars that still shine, to the galaxies that still spiral, to the universe that is still young and vibrant and full of interesting structure. This speed of light enters your awareness again, this cosmic speed limit, approximately 300,000 kilometers per second in vacuum, and you understand that this is not just the speed at which light happens to travel, but is more fundamentally the speed at which causality propagates, the speed at which information can move from one place to another, and nothing with mass can reach this speed because it would require infinite energy to accelerate to light speed. And even light itself can only travel at light speed when it is in vacuum. When it passes through matter, it slows down, not because the photons themselves move more slowly, but because they are absorbed and re-emitted by atoms, and this absorption and re-emission takes time, creating an effective slower speed through the material. And this is why light bends when it enters water or glass. While lenses work, the light slows down in a denser material, and this causes it to change direction according to Snell's law. And you think about how light has this dual nature, behaving sometimes as a wave and sometimes as a particle, and which behavior you observe depends on how you look, what kind of measurement you make, and this wave-particle duality is not unique to light, it applies to matter as well. Electrons and protons and even large molecules can behave as waves under the right circumstances, creating interference patterns when passed through small slits, just as light waves do. And this wave-like nature of matter becomes more apparent the smaller and lighter the particle is, electrons showing strong wave properties, protons less so, large molecules even less, and everyday objects like baseballs and planets showing no wave properties at all because their wavelengths are too small to measure or observe. But in principle even these have associated quantum waves, matter waves described by the Schrödinger equation, probability waves that tell you where you are likely to find a particle if you look for it, but that do not tell you exactly where it is before you look. And this indeterminacy, this fundamental uncertainty at the heart of quantum mechanics, used to trouble physicists, Einstein himself never fully accepted it, thinking there must be hidden variables that determine outcomes precisely, but experiments have shown that nature really is uncertain at its core, that the universe at its smallest scales is governed by probability rather than certainty, and perhaps this is fitting, perhaps certainty would be boring, perhaps the creativity and complexity of the universe arise from this fundamental openness, this quantum wiggle room that allows for variation and novelty. You drift past a planetary system, multiple worlds orbiting a central star, and you observe their spacing. Notice how they are arranged in a pattern that is not random but reflects the way the system formed from a rotating disk of gas and dust that surrounded the young star, and within this disk, particles collided and stuck together, growing from dust to pebbles to boulders to planetesimals, and the planetesimals gravitationally attracted to each other, merging into larger bodies, protoplanets, and these swept up more material from their orbital zones, clearing lanes in the disk, and eventually you are left with a set of planets in stable orbits of space according to the dynamics of the original disk and the gravitational interactions between growing planets. And close to the star where it is hot, only rocky planets can form because volatile materials like water and methane evaporate, but farther out where it is cooler, ice can condense and you can have much more mass available to build planets, and so you often find gas giants in the outer regions of planetary systems, massive worlds like Jupiter that formed quickly by gathering huge envelopes of hydrogen and helium around rocky icy cores. And these gas giants may have migrated inward or outward from where they formed, pushed and pulled by gravitational interactions with the disk and with other planets, and the architecture of planetary systems is thus a frozen record of their formation and evolution, and each system is slightly different, reflecting different initial conditions and different random events during formation, and you find this diversity beautiful. The way the same basic physical laws and processes can produce such varied outcomes, rocky planets and gas giants and ice giants and super-Earths and hot Jupiters and all the exotic types of worlds that the astronomers have discovered around other stars, thousands of exoplanets now known, and every one a world, a place with its own geology or meteorology or who knows what, and some of them might have life, simple or complex, familiar or utterly alien, and this thought makes the universe feel very full, very populated, even though space is mostly empty, even though the distances between stars are vast beyond human comprehension. Still there are so many stars and so many planets that life must have emerged in many places, and perhaps in some of those places it has become conscious, self-aware, wondering about their universe just as you wonder, and perhaps some of those conscious beings are also drifting now, also falling asleep under their own alien stars, also contemplating the cosmos and feeling small and large at the same time, connected to everything through the laws of physics and the shared heritage of cosmic evolution. The electromagnetic force, one of the fundamental forces of nature, holds electrons in orbit around nuclei, holds atoms together into molecules, holds molecules together into the structures of everyday matter. And this force between charged particles is described by Coulomb's law, force proportional to the product of charges and inversely proportional to the square of distance, and it is so much stronger than gravity that gravity is completely negligible for small objects. You never notice gravitational attraction between two people or two cars, but you constantly notice electromagnetic forces, friction and tension and the solidity of matter, all electromagnetic in origin, arising from the repulsion between the electron clouds of atoms that prevents them from passing through each other, and magnetism is a manifestation of the same force, a relativistic effect of moving charges. Electric charges in motion create magnetic fields, and changing magnetic fields create electric fields, and this interplay between electricity and magnetism is what light is, an electromagnetic wave. Oscillating electric and magnetic fields propagated through space, and Maxwell's equations, four elegant mathematical statements, describe all of electromagnetic phenomena, unifying electricity and magnetism and optics into a single coherent theory, one of the great triumphs of 19th century physics, and from Maxwell's equations you can derive the speed of light. It falls out of the mathematics naturally, a prediction rather than an input, and this speed turns out to be the same in all reference frames, always and everywhere 300,000 kilometers per second. And this fact, this constancy of light speed, seems impossible from the perspective of classical physics. If you run toward a thrown ball, you see it approach faster. If you run away from it, do you see it approach slower? But light does not behave this way. Whether you move toward or away from a light source, you always measure the same speed for its light, and Einstein took this fact seriously, accepted it as true, and worked out the consequences, and the consequences were special relativity, time dilation and length contraction, and the relativity of simultaneity, the realization that space and time are not separate absolute things but are unified into space-time, a four-dimensional continuum where your motion through space affects your motion through time and vice versa, and you understand this without needing the mathematics. You feel it in your drifting, feel how your journey through space is also a journey through time, how the two are intertwined, inseparable, two aspects of the same underlying reality. A comet streaks past in the distance, not fast and dramatic, but slow and graceful, its tail streaming behind it as the solar wind pushes gas and dust away from the nucleus, and you know that comets are ancient bodies, leftovers from the formation of the solar system, icy chunks that have spent most of their existence in the frigid outer reaches, in the Kuiper belt beyond Neptune or in the distant Oort cloud, and occasionally one of these comets gets perturbed, its orbit altered by the gravity of a passing star or the tidal effects of the Milky Way itself, and it begins to fall inward toward the sun, and as it approaches and warms, the ice sublimates, turning directly from solid to gas without passing through a liquid phase, and this gas carries dust with it, and together they form the coma, the fuzzy cloud around the nucleus, and the beautiful tails, one tail of dust pushed by radiation pressure, one tail of ionized gas pushed by the solar wind, and these tails always point away from the sun regardless of the comet's direction of motion, and comets have been seen as omens throughout human history, feared and wondered at, but now we understand them as messengers from the early solar system, as samples of the material from which the planets formed, and some scientists think that comets may have delivered water to Earth, impacting the young planet and contributing to the oceans, and perhaps they delivered organic molecules as well, the building blocks of life, and so life on Earth may owe its existence in part to these wandering snowballs, these frozen visitors from the outer dark, and this makes you feel a kinship with comets, a sense that you are all traveling together, all part of the same cosmic story. Your awareness of your physical body has faded almost completely now. You are not sure if you still have arms or legs, or if you have become pure awareness, pure observation, drifting through space and time as an immaterial witness, and this does not trouble you. In fact, it feels liberating, freeing, as though you have shed a heavy coat and can move more easily now, and the scientific concepts that float through your mind have become simpler, more intuitive, less like facts you are remembering and more like truths you are directly perceiving, and you understand that everything is vibration, atoms vibrating in their lattices, molecules rotating and bending and stretching. Even the quantum fields that underlie reality are states of oscillation, excitations in the electron field appearing as electrons, excitations in the photon field appearing as light, and all of nature is this symphony of vibration at different frequencies and amplitudes, harmonizing and interfering and creating the complex patterns we perceive as matter and energy and force, and you yourself are a pattern of vibration, a temporary arrangement of quantum fields that has somehow become self-aware, that can contemplate its own existence and wonder about the universe, and this pattern will not persist forever. Eventually it will dissipate. The vibrations that constitute your body and mind will spread out and become part of other patterns recycled by nature into new forms, and this seems right, seems natural, nothing to fear. Just another transformation in an endless series of transformations, and you relax into this understanding, let go of any clinging to permanence, accept the flowing temporary nature of all things including yourself. The weak nuclear force and the strong nuclear force, they are the two fundamental forces, operate only at very short ranges, distances comparable to the size of atomic nuclei, and the strong forces, which holds quarks together into protons and neutrons, and holds protons and neutrons together into nuclei, overcoming the electromagnetic repulsion between positively charged protons, and without this strong force there would be no atomic nuclei, no atoms, no chemistry, no stars, no you, and the weak force is responsible for certain types of radioactive decay, for processes that can change one type of quark into another, allowing neutrons to decay into protons or vice versa. And this weak force plays a crucial role in the nuclear reactions that power stars, particularly in the first step of the proton-proton chain, where two protons fuse to form a deuteron, a heavy hydrogen nucleus, and one of the protons must convert to a neutron via the weak force for this to happen, and this conversion is very unlikely, very slow, which is why stars burn so slowly, why the sun has been shining for billions of years and will continue for billions more. If the weak force were stronger, stars would burn out much faster and there would not be time for complex life to evolve. If the weak force were weaker, stars might not be able to fuse hydrogen at all, and the universe would be a very different and probably much less interesting place. And you marvel at this fine-tuning, at how the strengths of the fundamental forces seem calibrated to allow for a complex universe, for stars and planets and life, and whether this is coincidence or necessity or evidence of something deeper remains an open question, one of the great mysteries, and you do not need to solve it. You can simply appreciate it, appreciate that you live in a universe where the forces have the values they do, where complexity is possible, where consciousness can emerge and wonder. The constellations that ancient people saw in the sky were patterns they imposed on the random distribution of stars, connecting stars that had no physical relationship to each other, stars at vastly different distances that happened to lie along similar lines of sight from Earth, and these patterns, these constellations, help people navigate and tell stories and mark the seasons, the same constellations rising in the east at the same time each year as Earth completes its orbit around the sun, and different cultures saw different patterns in the same stars, projected their own myths and legends onto the sky, and this is a very human thing. This pattern seeking, this tendency to find meaning and order even in randomness, and perhaps it is related to the way your mind works, the way you perceive not raw sense data but patterns and objects, the way you instinctively group and categorize and understand things in terms of other things. And maybe this tendency toward pattern recognition is what allowed humans to develop science, the systematic search for patterns in nature, for regularities and laws, for mathematical relationships that describe how things behave, and science has been astonishingly successful at this, at finding patterns, at predicting outcomes, at understanding the universe in deeper and deeper ways, each generation building on the discoveries of previous generations. And the scope of human knowledge has expanded from the local and immediate to encompass the entire observable universe and the entire history of time from the Big Bang to the present, and this is remarkable. This is something to feel proud of as a human being, that your species has accomplished this, has reached out with minds and mathematics and instruments to touch the very fabric of reality, to understand things that no individual can directly perceive, the ultraviolet sun and the infrared earth, the microscopic bacterium and the cosmic web of galaxies, neutrinos streaming through your body from the sun, virtual particles flickering in and out of existence in the vacuum. All of this hidden from direct perception but revealed through careful thought and experiment, and you are grateful to be alive in a time when so much is known, when the accumulated wisdom of centuries is available to anyone who wishes to learn, and you can drift through space in your imagination, equipped with this knowledge, seeing the universe not as a mysterious and arbitrary place but as a rational, comprehensible cosmos operating according to discoverable laws. And this understanding makes the darkness less dark, makes the vastness less lonely, because you are not adrift in meaningless chaos but floating through a universe that makes sense, that can be understood, that rewards curiosity with insight. A neutron star appears below you, a stellar remnant left behind after a supernova, a sphere only 20 kilometers across but containing more mass than the sun, and the density is beyond comprehension. A sugar cube of neutron star material would weigh as much as Mount Everest, and the surface gravity is 200 billion times that of Earth, so strong that if you could somehow stand on the surface your body would be crushed into a layer less than an atom thick, and yet from your safe drifting distance you can observe this object peacefully, watch it spin at hundreds of rotations per second, watch beams of radiation sweep from its magnetic poles like a cosmic lighthouse, a pulsar. And the regularity of these pulses is extraordinary. Some pulsars keep better time than atomic clocks, their rotation is so stable, and astronomers have used pulsars as natural laboratories to test theories of gravity and to detect gravitational waves and to measure the properties of ultra-dense matter, and the material inside the neutron star is strange and exotic. Mostly neutrons pressed together so tightly that they touch, but in the core the pressure might be so extreme that neutrons themselves break down into their constituent quarks, forming a quark soup, a state of matter that has not existed anywhere in the universe since the first microseconds after the Big Bang. And you think about how extreme physics creates exotic states, how by looking at neutron stars and black holes in the early universe we can learn about the behavior of matter and energy under conditions that can never be reproduced in laboratories on Earth. Nature is the ultimate physics lab, running experiments at energies and pressures we can barely imagine, and we observe the results with our telescopes and detectors, and we try to understand what we see, and slowly, piece by piece, we build up a more complete picture of what matter can do, what forms it can take, what happens when you push to extremes. A black hole would be even more extreme, a region where gravity has become so intense that space itself is bent into a trap from which nothing can escape, not even light, and the boundary of this region is the event horizon, and anything that crosses the event horizon is lost to the outside universe forever, falling inexorably toward the central singularity where the curvature of space-time becomes infinite and our equations break down, and we do not know what happens at the singularity. Our theories lose their predictive power. Quantum effects that we usually ignore become important, and we need a theory of quantum gravity to understand it, a theory that does not yet exist in complete form, though string theory and loop quantum gravity and other approaches are trying to provide one, and until we have such a theory, the center of a black hole remains mysterious, a place where the known laws of physics cannot take us. And there is something satisfying about this, about having a clear boundary to our knowledge, a place where we know we do not know, rather than pretending to understand everything. And black holes teach us humility, remind us that the universe is more subtle and strange than we can currently grasp, and yet we have learned so much about them. We know they exist. We have detected gravitational waves from black holes merging. We have imaged the shadow of a black hole against the glowing accretion disk around it. And these achievements required incredible ingenuity and international cooperation and the careful accumulation of knowledge over decades, and you appreciate this, appreciate the collective human effort that went into understanding these most extreme objects, and you send a silent thank you to all the scientists and mathematicians and engineers who contributed to this understanding, who spent their lives pushing back the boundaries of ignorance, who chose curiosity over comfort and devoted themselves to discovering truth. Your breathing has become so slow now that you almost cannot detect it. Each breath a gentle tide that takes forever to come in and forever to go out, and you are fine with this. You do not try to breathe faster. You trust your body to breathe exactly as much as it needs to, and your heartbeat too has slowed, a distant gentle pulse, and your muscles are completely relaxed. You cannot feel any tension anywhere, and your mind is quiet. The stream of thoughts has slowed to a trickle, occasional words and images drifting by like clouds in a very slow breeze, and the scientific explanations have become simpler still, reduced to their essence, energy and matter and force and space and time, the basic ingredients of reality, interacting according to rules that are mathematical and precise but that can be felt intuitively. You do not need to know the equations to understand that planets orbit stars because of gravity, that light is a wave, that atoms are mostly empty space, that everything is made of energy in different forms, and these simple truths are enough. They provide a framework for understanding, a sense of how things fit together, and you rest in this understanding, this knowledge that the universe is knowable, that reality is not arbitrary but lawful, and the laws are beautiful, symmetric, elegant, and they were not created by humans but discovered by humans. They existed before anyone knew them, and they will continue to exist after everyone has forgotten them, carved into the deepest structure of being, and you are a temporary arrangement of matter that has become complex enough to perceive these laws, to understand them, to appreciate their beauty, and this is a gift, this brief window of awareness, and you are grateful for it, grateful to be here, grateful to drift through space, learning and wandering and slowly sinking into rest. The cosmic microwave background radiation surrounds you, fills all of space, this relic from the Big Bang, and it tells a story of the universe's beginning, how everything emerged from a hot dense state 13.8 billion years ago, how space itself expanded to carry matter and energy with it, and in the first 3 minutes nuclei formed, hydrogen and helium mostly, and then for hundreds of thousands of years the universe was opaque, filled with plasma, electrons and nuclei separate, scattering photons so light could not travel far, but then as expansion cooled things down, electrons and nuclei combined to form neutral atoms, and suddenly light could travel freely. and the photons from that moment have been traveling through space ever since, stretched by the expansion of the universe from visible light to microwaves. And now we can detect them. We can see the baby picture of the universe, see the tiny temperature fluctuations that were the seeds of all future structure, the sight over densities that would grow through gravity to become galaxies and clusters. And this is powerful evidence for the Big Bang theory. Along with the expansion of the universe and the abundance of light elements, three independent lines of evidence that all point to the same conclusion. The universe had the beginning. It has been evolving, changing, expanding for billions of years, and we are here in a relatively late stage, in an era when stars and galaxies exist, when heavy elements exist, when planets and life are possible. But this era will not last forever. Eventually the stars will die, the galaxies will dim. And if the expansion continues to accelerate, then in the far future, isolated black holes will be the last structures, slowly evaporating through Hawking radiation, and eventually even they will be gone, and the universe will be cold and empty and dark, maximum entropy achieved, nothing left to happen. But that is so far in the future that it is not worth worrying about. Right now the universe is alive with light and motion, stars are being born, planets are forming, life is evolving on countless worlds, and you are part of this grand story, one tiny thread in an enormous tapestry, and your existence matters. Not in a cosmic sense perhaps, the universe would continue just fine without you, but it matters to you. Your experiences are real, your understanding is real, your appreciation of beauty and truth is real, and these things have value even if they are temporary. Perhaps especially because they are temporary, the brevity of life makes each moment more precious, not less. You have been drifting for a very long time now, though time has become so fluid that you cannot say whether hours or years have passed, and you notice that your thoughts are becoming even simpler, less verbal, more like wordless knowing, a direct apprehension of how things are, and you understand without language that you are made of atoms that were forged in stars, that the oxygen you breathe and the carbon in your cells and the calcium in your bones all came from stellar furnaces, created through fusion and then scattered by supernova, and later gathered into a new solar system where some of those atoms ended up in you, and someday they will return to the cosmos, will be released back into space or buried in the earth or burned or scattered, and they will become part of other things, other patterns, other perhaps even other lives. And this is the way of things, the way matter flows through different forms. Nothing is permanent except the atoms themselves, and even atoms can decay, though most types take so long to decay that they are effectively eternal on human timescales. And you accept this, accept impermanence, accept that you are a temporary pattern in an eternal dance, and this acceptance brings peace, releases you from clinging, allows you to simply be here now, drifting and resting and letting go. The universe, you understand, is mostly empty. The distances between objects are so much larger than the objects themselves. If an atom were the size of a cathedral, the nucleus would be a grain of sand in the center, and the electrons would be motes of dust orbiting near the walls. Everything else is empty space, or rather empty quantum fields in their ground state. And even the particles themselves are not solid little balls but excitations and fields, momentary concentrations of energy that behave in certain ways under certain conditions. And at the deepest level, reality is not made of stuff but of relationships, of interactions between fields, of information encoded in quantum states. And this is strange and abstract but also beautiful, elegant. The universe is a mathematical structure, patterns of symmetry and broken symmetry, waves interfering and particles exchanging and fields permeating. And you do not need to visualize this. You cannot really. It is too far removed from everyday experience, but you can appreciate it, can marvel at how far human understanding has reached, from the simple observation that things fall down to quantum field theory and general relativity, from wondering why the sky is blue to understanding atomic spectra and Rayleigh scattering, from myths about thunder gods to Maxwell's equations and the electromagnetic spectrum. And each step in this journey required someone to think carefully, to question assumptions, to imagine possibilities, to test ideas against reality. And slowly, generation by generation, the edifice of scientific knowledge was built, is still being built. New discoveries still happening, new mysteries still being uncovered, and you are grateful to live in this time of knowledge, to have access to this understanding, to see the universe not as chaos but as cosmos, ordered and comprehensible. Gravity waves travel past you, ripples in space-time itself, caused by the acceleration of massive objects, black holes spiraling together and merging, neutron stars colliding, and these waves stretch and compress space as they pass. And on Earth, scientists have built detectors to measure these tiny distortions, using laser interferometry to detect changes in length smaller than the width of a proton, and they have succeeded. They have heard the universe raining like a bell, have detected dozens of black hole mergers, have opened a new window on the cosmos. Gravitational wave astronomy, complementing traditional electromagnetic astronomy. And this is how science progresses, new techniques leading to new observations, leading to new understanding. Each generation of instruments more sensitive than the last, each generation of theories more comprehensive, and there is no end in sight. There will always be more to discover, deeper levels to probe, new questions arising from each answer. And this endless frontier is part of what makes science exciting, the knowledge that we will never run out of mysteries, that the universe is generous with its wonders, that there will always be something new to learn for those who care to look. You feel yourself sinking deeper now, not falling but settling, like sediment drifting down through water, slow and peaceful. And the stars around you are dimming, not because they are going out, but because your awareness is turning inward, away from the external cosmos and towards interior darkness, the restful darkness of sleep. And you do not resist this, you welcome it. You have been drifting through space and learning about the universe, and now you are ready to rest, ready to let consciousness dissolve into unconsciousness, ready to sleep. And the last thoughts that drift through your mind are gentle ones. Gratitude for existence, appreciation for beauty, acceptance of the way things are, and you understand that the universe will continue without your awareness of it. Stars will keep shining, galaxies will keep turning, the laws of physics will keep operating, and this is fine, this is good, everything is exactly as it should be, and you can rest now. You have learned enough for today, you have traveled far enough, you can stop here and be still. The darkness is complete now, warm and soft, and you are cradled in it like a child in a mother's arms, safe and protected, and there is nothing you need to do, nowhere you need to go, no thoughts you need to think. You can simply be here, breathing slowly, heartbeat gentle, body completely relaxed, mind completely quiet, and the scientific concepts that filled your awareness have faded away. Return to wherever such things go when not being thought about, and in the place is simple peace, contentment, the satisfaction of having spent time learning and wondering, and now the reward of rest, deep restful sleep, and you drift down into it, down and down, deeper and deeper, leaving behind a waking world, leaving behind thoughts and awareness, becoming one with the darkness, one with the silence, one with the infinite peaceful present moment that has no duration and no location but simply is, and you dissolve into it, let go completely, and there's nothing now but rest, nothing but peace, nothing but the slow gentle rhythm of breath and heartbeat, and even these fade, become distant, become someone else's concern, and you are gone, you are asleep, you are nowhere and everywhere, you are the universe resting from its labors of being. And all is well, all is perfectly well, everything continues as it should, slowly, gently, endlessly, and you rest in this knowledge, this final understanding that everything is as it must be, and there is nothing to worry about, nothing to fear, nothing at all except this infinite gentle now. The cosmos continues its slow wheeling dance, stars forming and dying, galaxies clustering and separating, the expansion proceeding at its measured pace. And somewhere in all this vastness, on a small blue world orbiting an ordinary star, life continues, beings wake and sleep, love and learn, wonder and dream, and you are one of them, resting now, your consciousness dormant, your body maintaining itself automatically, your brain processing the day's experiences, consolidating memories, preparing for tomorrow, and all of this happens without your awareness, without your effort. The biological machinery of life carrying on its functions, molecules moving through cells, ions flowing across membranes, proteins folding and unfolding, DNA being read and transcribed, and at a higher level thoughts and dreams flickering through neural networks, patterns of activation moving through the brain like waves through water. And you are not aware of any of this. You are deeply asleep. You have completed your journey through space, your educational drift through the cosmos, and now you rest, and the universe rests with you, or rather you rest within the universe, supported by it, part of it, made of the same stuff as stars and planets, governed by the same laws, participating in the same vast unfolding story that began with the Big Bang and continues into an open future. And your small part in this story is to exist for a while, to be conscious for a brief span, to wonder and learn and appreciate, and then to rest, to sleep, to restore yourself for another day of being. And this rhythm of activity and rest is ancient, older than mammals, older than animals, older than life itself. The rhythm of day and night, the rotation of planets creating periods of light and dark, and life has adapted to this rhythm, built it into physiology. Circadian clocks ticking in every cell, and you are following this ancient pattern now, resting when rest is needed, allowing your body and mind to recover, and in the morning you will wake refreshed, ready for another day. Now the chance to experience the universe, to add your small voice to the chorus of consciousness that sings out across the cosmos. But for now you sleep, deeply and peacefully, dreamlessly or dreaming you cannot tell, and it does not matter. What matters is rest. Restoration, the healing darkness of sleep, and you sink into it completely. Nothing left of waking awareness, just the slow, steady functions of life continuing in the darkness. And this is enough. This is everything. This is the universe being itself, which is all it ever does, all it ever needs to do, being and becoming, existing and changing. And you are part of this, always have been, always will be in some form. Your atom's eternal, even if your pattern is temporary. And there is comfort in this, in knowing that nothing is truly lost. Everything is recycled, transformed, continuous with everything else. And you rest in this continuity, this connection, this belonging to the cosmos. And you sleep, and the universe sleeps with you. And all is quiet, all is still, all is perfectly at peace.